All right, we are on to section 3.4b. We are going to learn about slope-intercept form. And then I think in section 3.5, we are going to graph using slope-intercept form. Okay, so slope-intercept form is in this form, y equals mx plus b. The m stands for our slope, which we learned in the previous section 3.4a. And b is our y-intercept. And our y-intercept is where we cross the y-axis, the vertical line. Okay, so you're going to get this example. Here's the equation of the line. Y is equal to negative 2/3 x plus 3. And we have to determine the slope and the y-intercept. The slope is literally what sits in front of the x. So negative 2/3. You do not give the x. The x is not part of the slope. It's just the negative 2/3. The y-intercept is that number sitting behind. So the y-intercept is that 3, because remember our equation in slope-intercept form is y equals mx plus b. Well, the x's are the same, so you don't worry about the x. The x is not part of the slope, so don't give it. You will be marked wrong if you give that x, and the intercept is that b. Okay, it's just the number sitting behind. What if you don't have one of those things? Well, if you do not have an x, your slope is 0. If you don't have a number, then your y-intercept is 0. It's not a big deal. Another example. X or 7x plus y equals 5. Okay, what is my slope here? Okay, and many of you are going to go in and say slope equals 7. And I'm going to tell you that's wrong. It is not 7. You have to make sure that the problem is in the format y equals mx plus b. Okay, so if we have 7x plus y equals 5, we have to isolate the y, and we isolate the y, or get the y by itself, by subtracting 7x. Therefore, y is equal to negative 7x plus 5. Now, I have it in the format y equals mx plus b. Now I can determine the slope. So the slope is not 7, but rather negative 7. Okay, not too bad. What about this example? Well, once again, this example, we have to determine the slope. In order to find the slope, we have to get y by itself. So if you have 3x minus 2y equals 8, first thing you'll want to do is subtract the 3x from both sides. Okay, so then you would have negative 2y is equal to negative 3x plus 8. Do not combine the 3 and the 8. They are not like terms. They have to be the same, so they both have to be just numbers, or they both have to have variables. They both would have to have x's to combine them, so do not do that. Okay, now I need to get y by itself, so I'm going to divide by negative 2, divide by negative 2, and divide by negative 2. Note here I had to divide everything that way. So I have a negative and a negative, so that makes this a positive 3/2 x plus 4. So my m, or my slope, is equal to 3/2. All right, another example. We need to find the slope. So once again, you're going to have 55x minus 5y equals 1.2. I am going to subtract 55 from both sides of the equation and get negative 5y is equal to negative 55x plus 1.2. Divide by negative 5, divide by negative 5, divide by negative 5. y is equal to, double negative makes it a positive, 55 divided by 5 is 11x, minus, because I got a positive and a negative, so that's a minus, and I have no idea what 1.2 divided by 5 is. 0.24. So here, my slope is equal to 11x. All right. After you do several of those type of problems, you're going to move on to parallel lines and perpendicular lines. Okay? You know the lines, the two equations of the lines are the same if the m1 in the first equation is equal to your m2. Okay? So for example, y is equal to 3x plus 2, y is equal to 3x plus 1. Note how those threes are the same. Your slopes are the exact same. One could not be positive 3 and the other negative 3. It has to be exactly the same. For perpendicular lines, you need to have m1 is the same as the negative reciprocal of m2. Okay, so for example, if you had y is equal to 2/3 x plus 1, the perpendicular slope for the next equation would be negative 3/2. So the reciprocal means the numerator and the denominator switch positions, and you need it negative if that one was positive. But if 2/3 was negative, then 3/2 would be positive, plus 3. And that would make those perpendicular lines. All right, so here, the problem's going to ask me to determine whether the equations are perpendicular, parallel, and the third option would be neither. Okay, so here on this first equation, I'm going to look, my m is 3/4. I'm going to write that down. Write it down on the test so I know what you're doing. And negative 3/4. Okay, the 3/4 are the same, right? The answer is no, they're not. One's positive, one's negative. Okay, so that would follow, if you had a positive and negative, that might make it perpendicular, but they have to be reciprocals. So if you had positive 3/4, the reciprocal of that would be negative 4/3. And for it to be parallel, they have to be exactly the same. So they both have to be positive or both negative, which neither are. So the answer is neither. Okay, no big deal. You just continue on. Number 9. Okay, determine whether these lines are parallel or perpendicular. All right, for that first equation, I have to determine if that's parallel or perpendicular. I cannot determine that unless y is by itself. So I'm going to take x minus 4y equals negative 8, subtract x from both sides. So I get negative 4y is equal to negative x. Oh, negative. Let me do this. Negative x minus 8. Divide by negative 4, divide by negative 4, divide by negative 4. Therefore, y is equal to, now remember there's a implied 1, so I can leave it as 1/4. And is it positive or negative? Well, I've got two negatives, so it's positive x plus 2, because the double negative makes it positive. All right, so that's the first part. So this m is equal to 1/4. What is this, the second equation's m? Well, luckily for us, it's set up. It is 4. Well, they are reciprocals, but they're not negative reciprocals, so that doesn't make perpendicular.